Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 15, using the quadratic formula. Okay, I love the quadratic formula. It doesn't matter what type of problem you have, you can solve using the quadratic formula. And keep in mind what that means. If I have a quadratic and I graph it, and it looks like this, okay, a quadratic, that's positive, so A is positive. So if this is my graph, and this point right here and this point right here are our two solutions, okay, or roots, or zeros, okay, that means all the same things, roots, solutions, and zeros. So wherever this value is and wherever this value is, we can find using our quadratic formula. Okay, so solve this following problem. So the first step is we need to get this in standard form. And standard form is ax squared plus bx plus c equals 0. Where a is the number in front of x squared, it's called the leading coefficient. B is the number in front of our linear term, x, or our coefficient b, and c is our constant, or our number without a variable. So the first thing I need to do is get it in this form. This does not equal 0, so I need to move all of this stuff over here, and that's a 2x squared, and that's a minus 3x. I'm going to do both at the same time. In order to cross an equal sign, we have to do inverse operations. This is a positive 2x squared, so I'm going to subtract 2x squared. This is a negative 3x, so I'm going to add 3x. What I do to one side, I must do to the other. Lining up your x squareds and your x's, your like terms have to line up. So if I'm subtracting 2x squared from the right, I have to do it to the left. If I add 3x to the right, I have to add 3x to the left. That is our first step. Get your equation in standard form. The 2x squared minus 2x is 0. 2x squared is 0. Negative 3x plus 3x is 0. I now have a 0 over here, which is satisfying this part of my equation. 4x squared minus 2x squared is 2x squared. 5x minus 3x is 2x. 3 minus nothing, or 3 plus or minus nothing is still 3. So there we have our standard form. Now what I would like my students to do is tell me that A now equals 2. B equals 2, and I'm not going to call that C right now. C does equal 2, but this is not a perfect square, and I can't have a leading coefficient of 2. Okay? Actually, we're going to use the quadratic formula. I'm sorry, we're not completing the square. So C equals 3. That's not going to change. So now we have A is 2, B is 2, and C is 3. So there's my list of values. Be careful with your signs too. So now I'm going to use the quadratic formula, and the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4a times c, all divided by 2 times a. Okay, so I'm trying to find x. X is my value here and here, wherever they may be. Okay, so negative b. B is 2. Negative 2. Okay, this is just simple substitution. Write your square root. B squared. B is 2, so that's going to be 2 squared. Biggest problem with students is this piece right here. If that is negative and you square it, I see students putting a negative sign there. You will never get a negative number when squaring. This value right here under all radicals using the quadratic will always be positive. Okay, carrying on. Minus 4, and A is 2. I'll put that in parentheses. And C is 3. So this is just simple substitution now. All divided by 2 times A, which is 2. So x equals negative 2 plus or minus, I always do this radical first, 2 squared is 4, minus 4 times 2 is 8, 8 times 3 is 24, and it's minus 24 all over 2 times 2, which is 4. So simplifying that, I get x equals negative 2 plus or minus the square root of negative 20 all over 2. I'm sorry, that's still 4. All over 4. Okay, I now need to simplify this radical. So if I have a negative 20, that is negative 1 times 20. 20 is 2 times 10, and 10 is 2 times 5. So whenever I'm looking for perfect squares, I'm looking for something times itself. So 2 times 2 is 4. The square root of 4 is 2, so I can bring that outside. Negative 2 plus or minus over 4 is not changing. I'm just simplifying my radical. 2 times 2 is 4. Square root of 4 is 2, so I'm going to bring the 2 outside. Negative 1 is I, so I'm going to call that I. The square root of negative 1 is I, and I'm left with this 5, so that stays under the radical. Okay? So really what this means is it's a radical with negative 1. Let me break it up into different radicals just so you understand this step, what I'm doing. Times 4 times 5. And the square root of negative 1 is I. The square root of 4 is 2. And the square root of 5 is just square root of 5 because I can't remove it. So then I get 2i root 5, and that's what I have here. You just write it in number, the imaginary value I, and then the radical comes last. Now I have a 2 here in this term, a 2 in this term, and a 4 in this term. That means I can now reduce. So this will be negative 1 plus or minus 1i, or just I, square root 5, divided by 4 divided by 2, which is 2. So I just reduced these. So I got rid of these values and made 2's 1's and 4's 2's. And that is my answer. Okay? The first example I'm giving you happens to be an imaginary unit, which means that the quadratic would have been up here. And when you have an imaginary or an I in your answer, the solution is not on the x-axis. So that this tells us that our quadratic did not cross the x-axis. Okay? So now I'm going to erase this, get it out of the way, and we'll do B. Okay, so here's B. First thing I need to do is get it in standard form, and I need this to be 0, so I'm going to subtract 5c from both sides. Okay, so I have c squared minus 5c minus 14 equals 0. Identify A as 1, B is negative 5, and C is negative 14. Okay, because when I have c squared, 1c squared, A is 1. So now I write my formula. Let me get this distraction out of the way. So I write my formula, x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. I have my students write this every single time they do a problem because that is a memorization process. The more you write it, the easier it becomes to, the easier it gets to remember. Now I'm substituting. B, negative b. B is negative 5. This is a big mistake sometimes. So if I have negative b and b is negative 5, and negative is positive, so be careful. Okay? Do not write minus 5 there, or the whole thing will be wrong. Plus or minus the square root of b squared, that's negative 5 squared, minus 4 times a times c, which is negative 14, all divided by 2 times a. Now it's just simplifying. 5 plus or minus the square root. Negative 5 squared is positive 25. This is always positive, remember. Minus, negative times a negative is positive, so it's going to become plus 14 times 4 is 56. All over 2. So x equals 5 plus or minus the square root of 56 and 25 is 81. All over 2. This should have been the first example because this is going to come out very nice. So x equals 5 plus or minus the square root of 81, which is 9, all over 2. So then I'm going to split that up and say x equals 5 plus 9 over 2, or x equals 5 minus 9 over 2. So x equals 14 over 2, x equals 7, x equals 5 minus 9, which is negative 4 over 2, so x equals negative 2. So my two solutions are 7 and negative 2. Okay, what does that mean in the context of this problem? If I were to graph this, I know my parabola is opening up because a was positive, a is 1, and I know it's crossing at negative 2, which is here. Okay, and it's crossing at 1, 2, 3, 4, 5, 6, 7, all the way out here. And I know my parabola is doing this. So at this point, with this equation, that's all I know for now, is where it's crossing and what directions it's opening. The y-intercept is our c, negative 14. So this value here is negative 14. So actually this parabola goes way down like this. So it's supposed to be negative 14. And I can find this point here, but I'm not going to get into that right now. All I'm trying to explain to you is how to use this quadratic formula to find where the parabola crosses the x-axis unless it's imaginary. Okay, let's keep going. Move all this out of the way. They didn't give me enough room. Okay, slide this up. Solve for this using the quadratic formula. Solve. So this is already in standard form, so I'm just going to say a equals, there's nothing in front of the x squared, so it's 1. B equals negative 2. And C equals 1. Write your formula. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Substitute. Negative 2. Be careful. 2 plus or minus square root of b squared negative 2 squared minus 4ac all over 2 times a. Simplify. Negative 2 squared is positive 4, always positive. Minus 4 times 1 is 4. All over 2 times 1, which is 2. Simplify. 2 plus or minus. The 4 minus 4 is 0. The square root of 0 is 0 over 2. That just goes away. I have one solution. X equals 2 over 2, which is 1. Okay? That, my friends, is a double root. That's what that means. So a double root graph very quickly. Let's try that again. Y, X. I know my parabola is opening up because a is 1. I know my y-intercept is 1, so it's right here. That's 1. My c is my y-intercept. And I know my solution, my root, is 1. So if I go over 1, x equals 1 is right here. And when it's only one solution, it's called a double root. And what that means is the parabola is coming down. It touches and goes back up. It does not cross. So my parabola would look like that. That is what this formula is telling us, where these are crossing the x-axis, if they do. Okay. I'll keep going. Hopefully this will help. This is in standard form. A equals 3. B equals 4. C equals 8. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Substitute in negative b. B is 4, so it's negative 4. Plus or minus the square root of b squared minus 4 times a times c divided by 2a. X equals negative 4 plus or minus. Now I'm just simplifying. 4 squared is 16. 4 times 3 is 12. 12 times 8 is 96. It's minus 96 all over 6. This is going to give me a negative number. That means something here. Negative numbers under the radical will give us imaginary. The quadratic does not cross the x-axis, but we can still find our imaginary roots. So now x equals negative 4 plus or minus the square root of negative 80 all over 6. I'm going to simplify negative 80. It's negative 1 times 80, 2 times 40, 2 times 20, 2 times 10, 2 times 5. I have a pair of 2's here. I have a pair of 2's here. 2 times 2 is 4. 2 times 2 is 4. So I have a 4 and a 4, which is 16, and the square root of 16 is 4, so that's what's going to come out, and this is my I. So I'm going to get, if I have 2 of something, it becomes 1 on the outside. So x equals negative 4 plus or minus, okay, 4I, and my remainder, my lonely leftover, stays in, divided by 6. 4, 6, 4, 6, they're all even, reduces, negative 2 plus or minus 2I square root 5 over 3. We generally leave it like that. There are 2 solutions. They're both imaginary. Isn't this fun? Okay. Now let me clear all of this. Get it out of my way. And do the next problem. Okay. It gets so routine after a while. A equals 2. B equals 7. C equals negative 4. X equals negative b plus or minus the square root of 4. Negative b plus or minus square root of b squared minus 4ac all over 2a. X equals, now we're substituting, negative b is 7, negative 7, plus or minus b squared, 7 squared, minus 4 times a times c, all over 2 times a. X equals negative 7 plus or minus. Okay, once you get the hang of this, it gets quicker. Negative times a negative is positive. 4 times 2 is 8. 8 times 4 is 32, all over 4. X equals negative 7 plus or minus. 49 plus 32 is 81, all over 4. X equals negative 7 plus or minus the square root of 81, which is 9 over 4. So it's going to be negative 7 plus 9 over 4, or negative 7 minus 9 over 4. And that is going to come out to be 2 over 4, x equals a half, or x equals negative 16 over 4, or negative 4. And you should always check these and make sure when you plug them in you get 0 in your original problem. Okay. Practice makes perfect. I think I've done enough here to get you on the go with this. And this is just repetitive examples. But let me just do this one last one. I see something here. Just remember that this is not standard form. Let me do this one. So this one here is not in standard form. I need this to equal 0, so I'm going to subtract 3 from both sides. And when I do that, I get m squared minus 7 equals 0. Okay, think of that as m squared plus 0m minus 7 equals 0. Do not forget that. So a is 1. B is not there at all. There's no m, so that is 0. And c is negative 7. Now when I do my quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, and plug this in, b is 0, so that's a negative 0. There's no such thing, it's just 0. Plus or minus 0 squared minus 4 times 1 times negative 7 all over 2 times 1. That's going to equal 0 plus or minus the square root of negative times a negative is positive. 7 times 4 is 28. 0 plus 28 is 28 over 2. The square root of 28 is 2 times 14, which is 2 times 7. There's my pair of 2's that will come out and become 1. Remember, 2 times 2 is 4, so this becomes 2 root 7. So x equals plus or minus 2 square root 7 over 2, and the 2's cancel, so x equals plus or minus the square root of 7. And look at that. If you plug that in here, the square root of 7 squared is 7. 7 minus 4 is 3. All right. All right. If you have any questions about the real solutions, actually, maybe I should just do this. Maybe I will keep going. Can't hurt you. All right. Determine the number of real solutions for each quadratic equation without solving. First thing I'm going to do is move everything to the left. I'm going to subtract 8. I'm going to add 3p minus 8 under the constant plus 3p under the linear. Draw a line. P squared is just by itself, nothing changes. 7 plus 3p is 10p, and 33 minus 8 is 25. And that now equals 0. So A equals 1, B equals 10, and C equals 25. Now what they're saying here is says determine the number of real solutions without solving. So what they mean is in the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to go back and show you the examples we've done. Okay, so if I come back here, when our b squared minus 4ac was figured out here, 4 minus 4 is 0. When I get the square root of 0, we get one solution that's called a double root. Okay, so I'm going to go back now. So if this is called the discriminant, D-I-S-C-R-I-M-I-N-A-N-T, I think, discriminant. Okay, if the discriminant is the square root of b squared minus 4ac, if the discriminant equals 0, comma, 1 solution. If the discriminant is positive, then we get 2 real solutions. Okay, and let me go back and show you an example where I graphed it right here. When I did this problem here, let me find a better one that I didn't erase. Of course, I erased as I went. Okay. Well, look at here. This was 4 minus, that's going to be negative. That was negative. Where was my discriminant? Positive. Right here, we got an answer of 2, negative 2, and 7. So this was 25 minus, or plus, I'm sorry, 56. 25 plus 56, I erased it. 25 plus 56. Okay, so if I add 25 and 56, that was 81, and that gave me 9. And that gave me my solution here and here. So when the discriminant is positive, I get 2 real roots. Okay, and when the discriminant was negative, we ended up with I. And hopefully I didn't erase all that. I did. Okay. Anyway, since I erased it, I cannot go back. But when I get a negative under this radical, I get an imaginary. So therefore, we get 2 imaginary solutions. So there's the rule. There's only 3 outcomes. 1 solution when it's 0, 2 real solutions when it's positive, and 2 negative, or 2 imaginary solutions when it is negative. So now all I need to do is focus on negative b, not negative, b squared minus 4ac. So b squared is 10 squared minus 4 times 1 times 25. So that's going to be 100 minus 100, and that's the square root of 0. So 1 real solution. Okay, I didn't say real here, but it is. 1 real solution when it's 0. Okay, this one here, A equals 7, B equals 2, C equals 5. Square root of b squared minus 4ac. Square root of b squared is 2 squared minus 4 times a times c, which is the square root of 4 minus 140, which is the square root of negative 136. It's negative 2 imaginary solutions. Okay, because it's imaginary. Okay, this one. I need to subtract a y squared. I need to subtract a 4y. I need to add 3. I want 0 over here. That will give me 0. But I need to do the same on both sides. So minus y squared minus 4y plus 3 on the other side. And I get negative, or 2y squared minus y squared is just simply y squared. 10y minus 4y is 6y plus 3, because there was no constant over here. So there's my new equation. A is 1, the number in front of y. B is 6. I should have said the number in front of y squared. B is 6, it's the number in front of y. And C is 3, it's my constant. So I'm just going to write the square root of b squared minus 4ac. The square root of 6 squared minus 4 times 1 times 3. That will be the square root of 36 minus 12. The square root of 24. It is positive. I'm going to get 2 real solutions. Okay? And I will do this one last one. So I'm going to add 4z to both sides. Plus 4z. 4z squared is not a like term. I'm just going to put that out in front. There was no z. This is a z, not a 2. And so it's plus 4z plus 9 equals 0. A equals 4. Here's b. That is also 4. And c is 9. Okay. So I write the square root of b squared minus 4ac. Substitute. B is 4, so it's 4 squared minus 4 times 4 times 9, which is 16 minus 16 times 9, or 36 times 4 is 144. And 144 minus 16, 134, 124, 120, negative 128. Doesn't matter. We can easily see that it is negative. That will be 2 imaginary solutions. Okay, so I think I'm going to stop right there. Hopefully this was helpful to you in solving using the quadratic formula and what the discriminant means in the quadratic formula. Now go do your homework.